Hello guys, welcome back to EC TechNest. In this lecture, we will be discussing about the first module of digital image processing. Image. It is a two-dimensional matrix of pixel values. A pixel means picture elements. And the first one is grayscale. Grayscale has the value of 0 for black and 255 for white. It is represented as a function of f of x comma y, where f represents the amplitude or intensity of the image and x and y are the spatial coordinates. The discrete cosine transform is used to compress the image. In the further lectures, we will also discuss about the various transforms used to compress the image. We have RGB, that is the red, green and blue, to classify an image, and also we have YC and R, YCB and CR, which is for chrominance and luminescence. The word JPEG refers to Joint Photographic Expert Group. We'll discuss about each concept in detail now. So first, what is an image? An image may be defined as a two-dimensional function, that is a function of f of x comma y, where f represents the amplitude and x comma y are the coordinates of the system. So this is the image in the grayscale, and f of x1 comma y1 is equal to 179. So this is the color that is obtained for the coordinates, and the value is 179. The value ranges from 0 to 255 and the total is of 256 bits. Coming to the pixel, pixel is the most widely used term and it is used to denote the elements of a digital image. There are various spectrums and different sources of energy like gamma rays, X-rays, UV rays, IR rays, visible bands, microwave and radio waves. So this is the MATLAB code. It is written in the computer vision language. Image 1 is equal to I read of monalisa.png gray comma double. It is used to read the image, and IDISP represents the command to display the image. Next, we'll discuss about image processing and its classification. Image processing is classified into low level, mid level and high level. In low level, we are reducing the noise, contrast enhancement and image sharpening, whereas in the mid level, we are analyzing the image through segmentation. Segmentation refers to partitioning an image into regions or objects, and also classification. In high level process, we are learning, making inferences and actions and giving a sense to a set of recognized objects, and we also perform cognitive functions that is normally associated with vision. Here we can see the digital image processing and human vision comparison. Humans' electromagnetic spectrum of images is in the visible band, whereas in the digital image processing plus computer vision, it is in full spectrum, and it is processed by the brain in human beings and in computers in the digital image processing. The analysis in human beings is through hand or manually, whereas in the digital image processing it is through computers. So this is the electromagnetic spectrum, and it ranges from 400 to 700 nanometer in the visible spectrum. So the fields that use digital image processing would be gamma ray imaging, which is used to bone scan and to detect the infection or tumor. Next one is X-ray imaging. It is used in medical diagnostics, security check in public places. Next is ultrasound scanned imaging, that is sonography and industrial inspection. Imaging in visible and infrared band, that is remote sensing industry and law enforcement. Imaging in the radio band, such as the MR scanning. Computer vision is used in the field of robotics, telecommunication and cinema. This is one of the important topic and is mostly asked in exams and is repeated in most of the PYQs. That is the question would be like, explain the fundamental steps involved in image processing. You have to draw this diagram and explain about each block in 3 to 4 lines. So this is the fundamental block diagram of digital image processing. The first one is we choose a problem domain. You can write the explanation that I tell here, and I'll also share the notes in the description. So the first step is to choose a problem domain. Problem domain would be, first, whenever you identify a problem, you have to classify that into a domain to which it belongs. After classifying it into a particular domain, next is image acquisition. Image acquisition is the step in which you will acquire the image or capture the image through the digital cameras. Next is image enhancement. In some cases, the quality of the image will be reduced, so we have to enhance the image quality. And then image restoration. After improving the quality of the original image will be restored. Next is, if the image is in black and white and you want to color the image, color image processing is used. You can use RGB or CMYK. Next, wavelets and multi-resolution processing. Then you try to extract the in detail components from the image. After that, you compress the image. The compression would mean reducing the size of the image. Then you perform morphological processing. In morphological processing, you can either add components to an image or delete the components of an image. Next is segmentation. In segmentation, you will divide a single picture into multiple parts. And the next step is representation and description. In representation and description, you will have to describe what are the elements in the image and also clearly give a picture about what the image is. Next is object recognition. After the image is described and represented, we will be able to recognize what the image is from the picture. All these are interconnected to the knowledge base. So I'll explain about each block in detail now. So the first one is image acquisition. The image may be stored in the digital form or acquired by sensors or cameras and involves pre-processing such as scaling. Scaling is, you will try to increase the image quality by multiplying it by a scaling factor. Next is image enhancement. To bring out the details that is present in the image, we perform image enhancement, and it is the subjective area of image processing. Example would be increasing contrast of the image. Next one is image restoration. In image restoration, we are improving the appearance of an image, and based on the mathematical and probabilistic models of image degradation, we are trying to restore the image. Next one is color image processing. Color is a powerful descriptor and often simplifies the object identification, and therefore we'll use color image processing. After color image processing is done, next is wavelets. Wavelets is representing images in various degree of resolution. As we can see, when we watch videos, there is multiple resolution such as 240p, 360p and 480p and so on. In wavelets, we will represent the images in various degree. The next step is compression. Reducing the storage required to save an image or the bandwidth that is required for transmission is done in the compression process. The compression standard example is JPEG, that is the Joint Photographic Extension Group. Next is morphological processing. Morphological processing is a collection of non-linear operations that is related to the shape of the features in an image. In segmentation, we are partitioning an image into constituent parts or objects, and more accurate the segmentation, more accurate is the recognition. If the segmentation is done in a precise way, then we will be able to recognize what the image is. Next is representation and description. Representation is classified into boundary representation and regional representation. In boundary representation, we focus on the external shapes such as the corners and inflections, whereas in regional representation, we focus on the internal properties or the skeletal shape of the image. Next is description. Description is also called as feature extraction, which deals with extracting attributes from an image. Recognition. Recognition is we are assigning a label to the object based on the description. Knowledge base. Knowledge about a problem domain is coded and it is the form of a knowledge base. It also controls the interaction between the different modules.